Section 210.11 of the National Electrical Code addresses branch circuits required for dwelling units. It mandates that specific circuits, such as those serving bathrooms and kitchens, be provided with overcurrent protection, often achieved using a 20-amp circuit breaker. This requirement ensures that the circuit can safely handle the anticipated load. The question often arises whether the ground fault circuit interrupter, or GFCI, devices installed on these circuits must also be rated for 20 amps. The answer is no. The GFCI receptacles themselves do not necessarily need to be rated for 20 amps on a 20 amp circuit. The 20 amp rating specified in section 210.11 pertains specifically to the overcurrent protective device, which is the circuit breaker or fuse that supplies the branch circuit serving the protected bath or kitchen areas. This overcurrent protection device is designed to trip and interrupt the circuit if the current exceeds 20 amps, thereby preventing overheating and potential fire hazards. GFCI devices are primarily intended to protect against ground faults, which are unintentional electrical paths between a live conductor and ground. These devices monitor the current flowing to and from the load and quickly interrupt the circuit if a difference is detected, indicating a ground fault. The amp rating of a GFCI device indicates the maximum amount of continuous current the device can safely handle. A 15-amp GFCI receptacle is designed to handle a continuous load of up to 15 amps without overheating or failing. When a 15-amp GFCI receptacle is installed on a 20-amp circuit, the circuit breaker will still provide overcurrent protection for the entire circuit. If the total current drawn by the loads connected to the GFCI receptacle and any other outlets in the circuit exceeds 20 amps, the circuit breaker will trip, protecting the wiring and devices from damage. It is important to note that the National Electrical Code does allow for 15-amp receptacles to be installed on a 20-amp circuit under specific conditions. These conditions are primarily outlined in section 210.21b3, which addresses the permissible loads on branch circuits. This section states that where a branch circuit supplies 2 or more receptacles or outlets, the receptacle rating shall not be less than the branch circuit rating. However, there is an exception. Where connected to a 20-amp branch circuit, 1 or more receptacles shall be permitted to be rated at 15 amps. This exception acknowledges that it is common practice to install 13-amp receptacles on 20-amp circuits in residential settings, particularly in kitchens and bathrooms where multiple small appliances may be used. The key to ensuring safety is to ensure that the total load connected to the circuit does not exceed the circuit breaker's rating. The reason this is permitted is because most general-purpose receptacles are rated at 15 amps. If a 20-amp receptacle were required every time a 20-amp circuit was installed, it would limit the types of equipment that could be plugged in. The code recognizes this practicality. However, if a single receptacle is installed on a 20-amp circuit, then that receptacle must be rated for 20 amps. This prevents someone from plugging in a device that draws more than 15 amps into a 15-amp receptacle on a 20-amp circuit. To further clarify, consider these points. Firstly, the circuit breaker provides overcurrent protection for the entire circuit, regardless of the amp rating of the GFCI receptacle. Secondly, the GFCI receptacle provides ground fault protection, which is independent of the overcurrent protection provided by the circuit breaker. Thirdly, the NEC permits 15-amp receptacles to be installed on 20-amp circuits under specific conditions. Fourthly, it is crucial to ensure that the total load on the circuit does not exceed the circuit breaker's rating. When selecting GFCI devices for bath and kitchen circuits, it is important to choose devices that are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories, or AL. This ensures that the devices have been tested and meet safety standards. It is also important to follow the manufacturer's instructions for installation and wiring. Improperly installed GFCI devices may not provide adequate protection against ground faults. In summary, while the circuit breaker supplying a bath or kitchen circuit may be rated for 20 amps as required by section 210.11 of the National Electrical Code, the GFCI devices installed on that circuit do not necessarily need to be rated for 20 amps. A 15-amp GFCI receptacle is acceptable, provided that the circuit breaker provides overcurrent protection for the entire circuit and the total load in the circuit does not exceed the circuit breaker's rating. It is crucial to consult the National Electrical Code and local electrical codes for specific requirements and to ensure that all electrical work is performed by a qualified electrician. A crucial aspect to understand is the concept of ampacity. Ampacity is defined as the current, in amps, that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including its size, insulation type, and the ambient temperature. When selecting conductors for a branch circuit, it is essential to choose conductors with an ampacity that is sufficient to carry the anticipated load. For a 20 amp circuit, the conductors must have an ampacity of at least 20 amps. Typically, this would require using 12 American wire gauge or all copper conductors, which have an ampacity of 20 amps under most conditions. However, it is important to consult the ampacity tables in the National Electrical Code, such as Table 310.15b16, to determine the appropriate conductor size for specific applications. In addition to ampacity, it is also important to consider voltage drop when designing branch circuits. Voltage drop is the reduction in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To minimize voltage drop, it is important to use conductors that are large enough to carry the load and to keep the length of the circuit as short as possible. Another important consideration is the type of wiring method used for the branch circuit. The wiring method refers to the way in which the conductors are installed and protected. Common wiring methods include non-metallic sheathed cable, or Romex armored cable, and conduit. Each wiring method has its own advantages and disadvantages, and the choice of wiring method will depend on the specific application and local code requirements. Non-metallic sheathed cable is a common and relatively inexpensive wiring method that is suitable for use in dry locations. Armored cable provides additional protection against physical damage and is often used in commercial and industrial settings. Conduit provides the highest level of protection and is typically required in areas where the wiring is exposed to moisture or physical damage. When installing electrical wiring, it is crucial to follow all applicable codes and regulations. The National Electrical Code is the most widely adopted electrical code in the United States, but many states and local jurisdictions have their own electrical codes that may be more stringent. It is important to be familiar with the codes that apply in your area and to ensure that all electrical work is performed in accordance with those codes. In addition to the National Electrical Code, there are also a number of other standards and guidelines that may be relevant to electrical installations. These include standards published by the Institute of Electrical and Electronics Engineers, or IEE, the National Fire Protection Association, or NFPA, and Underwriters Laboratories, or AL. These standards provide detailed information on various aspects of electrical design, installation, and safety. Ground fault protection is a critical safety feature that is designed to protect people from electric shock. Ground faults occur when there is an unintentional electrical path between a live conductor and ground. If a person comes into contact with a live conductor and ground at the same time, they can receive a severe or even fatal electric shock. Ground fault circuit interrupters, or GFCIs, are designed to detect ground faults and quickly interrupt the circuit, thereby preventing electric shock. GFCIs work by monitoring the current flowing to and from the load. If there is a difference of more than a few milliamperes between the two currents, the GFCI will trip and interrupt the circuit. GFCIs are required in many locations, including bathrooms, kitchens, and outdoor areas. They are also recommended for use in other areas where there is a risk of electric shock, such as garages and basement. There are two main types of GFCIs. Firstly, receptacle type GFCIs, which are installed in place of standard receptacles, and secondly, circuit breaker type GFCIs, which are installed in the electrical panel. Receptacle type GFCIs are typically used to protect individual outlets, while circuit breaker type GFCIs are used to protect entire circuits. When selecting GFCI devices, it is important to choose devices that are listed and labeled by a recognized testing laboratory, such as UL. This ensures that the devices have been tested and meet safety standards. It is also important to follow the manufacturer's instructions for installation and wiring. Improperly installed GFCI devices may not provide adequate protection against ground faults. Electrical safety is paramount, and it is crucial to take precautions to prevent electric shock and other electrical hazards. Always turn off the power before working on electrical circuits. Use insulated tools and equipment. Never work on electrical circuits in wet or damp conditions. If you are not comfortable working on electrical circuits, hire a qualified electrician. By following these safety precautions, you can help to prevent electrical accidents and injuries. The information provided here is intended for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Furthermore, always adhere to local and national electrical codes and regulations. Understanding the requirements for GFCI protection in bathrooms and kitchens is crucial for ensuring electrical safety in residential buildings. While the branch circuits supplying these areas may be rated for 20 amps, the GFCI receptacles themselves do not necessarily need to be rated for 20 amps, as long as they meet the requirements outlined in the National Electrical Code and are properly installed and maintained. This comprehensive explanation provides a clear understanding of the ampacity requirements for GFCI devices in bath and kitchen circuits, emphasizing the importance of adhering to electrical codes and ensuring proper installation for electrical safety.